Hi, my name is Rishav, and I'm applying to the 2014 Davidson Fellowship. So, I am now in the final process of the submission, which is the video. And I have to say, it has been such an amazing experience to be able to submit to such a phenomenal scholarship. And I have to say that my Huntington's disease project really means a lot to me. Not only because it has so much significance for the future and that it could help many people, but it also has made me grow very highly intellectually as a student. You see, I was inspired by my project by a recent experience I had in India. And I used to play chess with my uncle, and he used to always beat me at chess, and I was never that great at chess. But one day, when I came to India, and when I knocked on his door, my aunt told me that he had been diagnosed with Alzheimer's disease. And that was a very shocking experience for me, because he is someone who I generally loved as a person, and who I thought I could share a lot with. And now that he has Alzheimer's disease, he couldn't recognize who I was. And so, not only could he not recognize me anymore, I could not play what I love to play the most with him, chess. And so, because of that, I wanted to do something about it. And so when I came back to the United States, the summer before starting my sophomore year of high school, I started to do some independent research on my own, on my computer, trying to understand what Alzheimer's disease is. And a lot of neurodegenerative diseases besides Alzheimer's are related to the idea of protein folding, and how, because these proteins are misfolded, they cause very dangerous effects in cellular systems. And so I wanted to do something about it by perhaps trying to refold these proteins so then they could restore normal brain function. But of course that's not possible without any form of genetic manipulation. And so in order to do such experiments, I would need a lab. And so I asked my dad for help, and my dad told me that I could talk to one of his colleagues at the Keck Graduate Institute of Applied Life Sciences. And from there it was all history. So I started to talk to my mentor there, Dr. Animesh Ray, who told me about the complexities of neurodegenerative diseases, and also other work that's being done at Keck. And so I asked him if there was a way I can get involved. And he told me not necessarily yet with neurodegenerative diseases, but definitely with the topic known as chromosome instability, which is being undertaken by one of his graduate students, Jesse. And so I've been working with Jesse for a while. And after my experiences of working with Jesse on chromosome instability, I learned a lot about genetic manipulation in different aspects, and I also learned how to think more creatively out of research. And since Jesse was trying to get his PhD, I also got a small introduction into the graduate level process. And working in a graduate lab has really shaped a lot of who I am now. Not only a mature thinker, but also just how I approach problems. I approach them in multiple perspectives, not only one. And that interdisciplinary nature that I developed is a very important aspect of any researcher, I believe, in the future. And so the study that I have done on Huntington's disease with my mentor's group at Keck, it truly has a huge significance for the world, because not only is it improving Huntington's disease patients by uncovering future biomarkers for drug development in yeast as well as humans, but it also has implications in several related diseases known as the polyglutamine trinucleotide disorders. And so in these disorders, the mechanism is very similar to Huntington's disease. And so a similar approach of using ribosomal overexpression can be used in those disease systems as well. And their drug development targets could be found, and then a lot more people can be treated rather than just 10,000 people. And I honestly believe that it has a great implication in major neurodegenerative diseases, such as Alzheimer's disease and Parkinson's disease. So I'll be able to help my uncle one day. And the reason why I say that is because since all these diseases are related to protein folding, and since all these diseases may have some relation with ribosomal function, I think it is worth trying to experiment with ribosomal overexpression on the disease systems of Alzheimer's disease and Parkinson's diseases, because I believe that it will be able to clearly make us understand what exactly the protein folding problem is and how it can be manipulated. And perhaps the ribosomal overexpression that's been done in my project may be the answer to uncovering the complexities of the other major neurodegenerative diseases. And so I believe that that just research on one disease can truly uncover so much about other diseases, since they're all related. And another major thing I would like to highlight is that since this is a rare disease, a lot of research hasn't really been done on rare diseases. And so I think this is not only a progressive step in just research for many diseases, but it is also a huge step towards helping those who really need care urgently. Because many pharmaceutical companies are making drugs for very common diseases. But since Huntington's disease is not a common disease, it is hard to get into the market. But because it is rare and not many people have it, human trials will become faster, and so developing the drug will not take as much time as a common disease. And so I think it's a great step towards helping those people. And a lot of people tell me that, Rishav, you're helping those people who think to themselves, why am I the one who has this disease that not many people have? Those people won't have to worry anymore because help is coming in the way. And I truly believe that I'll be the one who uncovers the ribosomal overexpression secrets in future diseases and develops drugs for them. Thank you so much for giving me a platform to demonstrate the rigorous work that I have done in the past 1.5 years. I look forward to hopefully becoming one of the 2014 Davidson Fellows. Thank you so much.